Okay, let's take a look. This is for homework 1.12. For this part of the assignment, you're going to need one of these, which hopefully you picked up on the way in. The reason you're going to need this is because we're going to assemble some of these compounds based on the charges of the ions. Okay. One thing to know about ions is ions are metals. Okay, so we'll have something over here in the metal category added to either a nonmetal or a polyatomic ion with a negative charge. Now, the negative charges indicate how many electrons are being received. So for this oxalate, it's got a -2 charge. It's receiving 2 electrons. Those 2 electrons either have to come from one beryllium, which will lose 2 electrons becoming +2, or will come from a single lithium or sodium or potassium, okay? So whatever electrons are received, indicated by a negative charge, has to come from another element indicated by its positive charge. So these guys have 1 electron, 2 electrons, 3, and then there's a variety of different electrons that are to be offered. Now, in order to do these balanced equations, and N1.12, notice that there is a line that strikes through some other things, detailed ionic equation, spectator ions. You don't have to do those yet. We're going to talk about those tomorrow. All we're doing today is writing out the basic molecular equation, okay, in all of its glory. Okay, so make sure you leave yourself some room. Okay, these equations should only go in this area here. They shouldn't really fall in any of this space here. We're going to add some more stuff to it. All right, so let's look at the first one that we have here. The first thing we want to do is take our 2 reactants and turn them into a formula. So notice I've got lead nitrate, all right? And so I'm going to write down what I have here. I got Pb, and it's going to be positive something, and then I'll have nitrate, which is NO3 minus. Okay, NO3 minus. So nitrate. Now, when you look, the reason why I didn't put a charge here for lead is because I have to look at and find it on a periodic table. It's over here. And notice I have 2. I've got lead +2 and lead +4. When given an option to choose, we're going to use the top one. This table here lists the most common ion for these elements on top. Unless it's indicated by a Roman numeral, we're going to choose whatever is in the top part of our box. So this is lead nitrate +2. Okay, now notice that we don't have a balanced charge here. We got +2 and we got -1 here. What that indicates is this: the nitrate can receive as a polyatomic only 1 electron, but lead has 2 to give. So what we're going to do is we're going to add a second nitrate. Okay, so lead nitrate, here's our formula for that. Okay, ion 1, ion 2. All right, we're going to add that to potassium chloride. And we have K and Cl. Now these are a little bit more straightforward because potassium has a +1 charge, so we're going to put our K plus on there. And then chlorine is over here, and it's a -1. Okay, so that one is nice and easy. It's already balanced out. All right, now we're going to do some work to predict the new combination. Now this sets up like a double replacement. Okay, and double replacement reactions is where we see the positive cations or the positive ions replacing each other. And so what we end up getting is this. Here's our yield sign, Pb +2 Cl minus plus KNO3. Okay, and we'll put the charges on here as well to show what we have here. Okay, now notice in this new form I do have to put parentheses around the chlorine too. Okay, I actually don't. You don't have to. If you want to, you can. And it makes it PbCl2, and this is KNO3. Okay, so here's our completed formula. I'm going to clean this up a little bit, make it look a little bit prettier. PbCl2 plus KNO3. Now the last thing we need to do here is we do need to balance the equation. Okay, so I have 2 nitrates here. I'm going to put a 2 here. All right, that doubles up the amount of potassium I have, and I'll put a 2 here as well. Okay, so 1 lead, 2 chlorine, 2 chlorine, 2 potassiums, 2 potassiums, 2 nitrates, 2 nitrates. So there is my working formula, and this is already done on your sheet. If you want to do it on scratch paper, that's fine, but this would be my final product. Okay, so here is our complete molecular equation. All right, so this is what you're looking to do for homework for 1.2. Once again, ignore the other 2 sections on here. Okay, so the detailed ionic and strike out spectator ions. We're going to get to that tomorrow. All right, but this is what the homework should look like tonight. All right, thanks. Have a good day, guys.